All right. Then, welcome everyone to our second edition of the Rust Munich meetup this year. Yeah, glad to see so many new faces. So it's really cool to see the community growing. It's really nice. Also today we have a hybrid meetup, so there will be a live stream on YouTube, just that you know. Yeah. Today we are here at MGM Group. Yeah, would really like to highlight and thank Diana and Ludwig for making this possible. Without you, this would not be possible. So give them a warm hand of applause. And before we come to the agenda and the talks, I would like to give the stage to Ludwig to tell a little bit about MGM Group and what you guys doing and how Rust is maybe connected to your life. So, Ludwig, stage is yours.
Yes, hello. I'm Ludwig from MGM Group. MGM is about 30 years old, has about 1,000 employees, and in 19 locations worldwide. We are mostly in the public sector, in e-commerce, and in industrial insurance. And I'm in a part that does security, which is MGM Group has several sub-companies, and I'm with security partners. We are doing pen testing and web security, and also a bit of product development. If you have any questions, come to me, ask me, or to Diana and ask her. She's from MGM Technology Partners, by the way, and a little bit of organizational stuff. As we already said, food, drinks are in the room, and toilets are on the corner. And it would be nice if you could give back the lanyards at the end, so because it's better for the environment, we are reusing them. Yeah, thanks, and enjoy the evening.
Thank you. All right, then the agenda for today. We have our first speaker, Heiko, which will introduce us to the distributed tracing world. And after that, we will have 20 minutes roughly for food and snacks, drinks, of course, a bit socializing. And then I will go ahead with the next talk. And that will be about parsers, like pack parsers in Rust. And then, yeah, we can like have some more drinks and relax a little bit, talk a little bit, and then the show will be over. All right, good. Then, Heiko, welcome on stage.
Thank you, and hi everybody. Wow, I think my last Rust meetup was maybe in 2019. Maybe it was in 18, I don't know. So it has been a long time. And yeah, you probably don't know me because before I became a Rustasian, I was deep into the Scala community. And there I gave talks and at conferences, meetup groups, etc. But actually, this is my first talk at the Rust meetup. So it's pretty good to be here. Today, I'm going to talk about distributed tracing in Rust or for Rust. And this is not a talk with a lot of slides. Actually, I don't have a single one. But I will show you a lot of live code and how to do it. And please feel free to ask questions at any time. I'd like to have a conversation instead of a classic talk, if that's possible. All right. Distributed tracing. Has anybody an idea or even some experience with it? Who has already used it? Only 1, 2, 3. Okay. So tracing is part of a bigger theme that is called either telemetry or observability. And there's actually a standard for that. It's called Open Telemetry. And if you look there, there's a primer. And that defines a couple of things. And the most important for you is if you talk about observability, it's about traces, metrics, and logs. I'm pretty sure you all know logs, right? Whether you are using Rust or Scala or C or whatever language, you probably write some logs, right?
Short interruption, sorry. There is something wrong with the screen share. We cannot really see your screen here.
Okay.
It is still showing this picture here. This is really strange. Sorry for the interruption.
Okay.
Let me see. We can fix
Oh,
that.
maybe präsentieren.
Let's turn it on and off again.
Mm-hmm. Yeah, because it was sleeping. Yeah, okay.
Maybe, yeah.
Yeah, let's do it.
Let's see. This is
Go back to StreamYard.
yeah.
Cancel the sharing.
This one?
The next one. Okay, go to share now. And now over here, you select
The whole screen?
Yeah.
Yeah, I think that's what you did.
Yeah, that's what they did.
Now I have to add you on stage. And it's frozen. The F. This is really unfortunate.
We should have used Zoom.
Yeah.
It always works. It's expensive.
But there was this note down, your backstage.
Let's try again.
Sie sind backstage, nur der Gastgeber kann sie sehen.
Yeah, now because we reloaded.
Technology.
Yeah. It's amazing. So that's
The camera is working. As a hack, you can put the camera here.
Yeah. That's probably better.
That's also an option. Yeah.
That was the famous green screen. Do we have it?
Yeah, now it's sharing the browser, so it's working. So
Ooh.
do you show the console as well?
Yes.
Then,
Like here.
Yeah. Then it's all right. Then we just have slides, no console.
Sorry for you guys who are online. It's not my fault.
Yeah. Let's blame the StreamYard. Like MMA. All right. So. Sorry.
All right. We stopped at logging. So logging is one part of observability. I think it's super important. When it comes to tracing, it's also very important to be able to connect logs to traces and vice versa. And this is something I'm going to show you, okay? Now this is OpenTelemetry. It's a standard. It's implemented for various languages. We're using Rust today, obviously. And in Rust, there's a couple of libraries to support that. So let me switch over to my pet project, which I have here. And let me increase the font a little bit. Can you read it? Is it okay? Great. So I have a couple of dependencies in my project. Let's scroll down first. So here we have tracing. It's Tokyo tracing. Do you know Tokyo tracing? Some of you know, like 50%. It's essentially the library we are going to use for tracing, but it's misnamed because initially it sort of only supported logging. It also supports tracing and also a little bit supports metrics, but this is out of scope today. So this tracing library is sort of the nowadays go-to library in Rust when it comes to logging and tracing. And then we have some other libraries like tracing subscriber, which is a good friend of tracing. And then we have tracing OpenTelemetry, which bridges the Tokyo tracing to OpenTelemetry. And we have a couple of other crates here. We don't dive into all of them. Okay, so first let me show you how you can use the Tokyo tracing library to log something. Now the Now, pet application here is essentially two services. One is a HTTP service, and the other is a gRPC service. And the one is called gateway. It's a hello gateway, so it can send hello HTTP requests, and it will forward it to the backend, which is gRPC that will respond with a nice hello text, and then this will be used to complete the response. Okay, so very, very simple. And to run one of those, we have the main files, and here you can see examples of how to use the tracing library for logging. So for example, here, let's not start with an error, let's start with something positive. So here we have info. That's a message at info level. It's just starting. And the cool stuff about the tracing library is that you can put additional fields onto the log messages. And if you use structured logging, like JSON, those will be JSON, parts of your JSON object, like fields in your JSON, okay? So here we are using the config. And this special notation just means that you want the field to be named config, and the value you want to be config, and its debug representation. Okay, you could also write debug. So it needs a debug implementation, okay? And the same is possible for things that implement display. Then you use display, or don't use the question mark operator, but this one here, the % operator. That is for the display representation, which this one doesn't have. Okay, so this is logging. Pretty straightforward. How does it look like? So if you run this thing, sorry, yeah, let's run the backend, doesn't matter. You will see some nice JSON output here, the timestamp, level, and so on. And here you can see the config field. The message is starting, which we had here. And then you have the config field. And this is the debug representation of the configuration of this simple service, okay? So that's logging. Any questions so far? No, cool. I haven't shown you how to configure that. I will do that now. As both backend and gateway are using the same approach to logging and tracing, I have put that into a common library. And essentially, if you want to initialize your tracing, you have this tracing subscriber crate, and you have to do something like this here, okay? And ignore this line for the time being. So what you can do is you can start with an environment filter, which allows you to use an environment variable called Rust log, which you might know from the log crate or the env logger crate and so on. And then this will just take your Rust log, info, level, etc. settings from the environment. And then this is the interesting thing. If you want to use structured logging with JSON, you use format layer JSON. And I used flatten event, which means that the fields will be flattened instead of in a sub object called fields. And then you initialize it and you're good. So that's for logging. But now let's talk about tracing. And before we talk about it, I want to show you how to use it and what it gives you, okay? First, a very high-level description. What is a trace? What is tracing? As opposed to logging. Logging gives you information about things that have happened, about logging events, okay? Tracing, on the other hand, gives you information about a flow through your program. For example, if you have a service, request response service, it gives you a flow from whenever the request is received across the handlers and functions that are called until the response is sent back. Okay? So you get additional insights into your system, because if an error happens at some point in time, like in some function which is called by some handler, I don't know, you have a SQL error or whatever, and you don't know exactly, if you look at the logs, okay, this is wrong SQL, but I don't know what were the inputs and so on. Then you look at the trace, and then you can see, oh, there was a request which wanted to do this and had those parameters. So you get this additional information, this additional context, and that's super helpful. In particular, if you have a service-oriented microservice architecture and you have distributed tracing where the trace spans all the services until the response, okay? Then you get this additional context, which you probably don't have if you just look at the log message, at the error message, or whatever. Okay, so let's look at the example. I have it deployed in Minikube because I need some component called OpenTelemetry collector that sends it to Grafana, which is the backend I'm using here. But it's still those two services. And the important one is exposed here. And I can invoke it like this. So I just use the URL and hello. And I get back a nice message. Hello, I'm built with Rust. And then again, hello, I'm a tracing demo. And that's all it can do, like send those two responses. But as I already said in the beginning, there's a lot going on behind the scenes. So you have this gateway service, which is this HTTP API. But then you have the backend service, which actually creates those responses. And so the HTTP service, the gateway service, is talking to the backend service via gRPC. And that could, of course, fail. We can scale down the backend. And once that has happened, this should no longer work. And as you can see here, we get an internal server error. And now it would be good if we were able to analyze that, okay? And luckily, we have tracing. So let's take a look at the browser again. And I think the people who are online are happy again. I'm using Grafana as a backend for logging and tracing. You could use Datadog or anything else. I'm choosing the last 5 minutes, and I update that. Oh, it's not updating, is it? Oh, it has already updated. That's cool. So you have the logs down here. Why is it down there? Anyway, it's pretty hard to read. I can increase it. So as you can see here, we have 2 errors and a couple of debug messages before. Let's take a look at the error. So we can make it a little better looking. So we have a couple of things here. But as you can see, it's really not giving us too much insight. There was just unknown service. OK, yeah. But the cool thing is what we have here is a trace ID. So the logs carry the trace ID. And I will later show you how to do that. And when you do that, you are able to go from the log event to the trace by just clicking that button here. And this takes us to the trace. And it's a little hard here. OK, here you can see what it looks like. No, I think I have to reset the. No, should I reset the display resolution, or will that screw up everything? It will screw up everything, I guess. OK. So.
You can reset the zoom in the browser, maybe.
Maybe that's the problem. OK, thank you. No. So this is not looking as it should look like. It only gives insight to the gateway, unfortunately. OK, I will change the display settings. Bear with me. Where did we do that? Was it here, standard?
Yeah.
OK. OK, for some reason this is broken. It doesn't. I cannot scroll down here. Great. Okay, I will try to change that a little bit. Was it already 15 minutes ago? Come on. All right, this is no good.
Question: when you changed your code, did you redeploy your code, or was it running before you started the talk? Because you removed one line, right?
Yeah, that didn't matter. Good point, but no, I have deployed it into Minikube, and that was just another version. But hey, I don't know. So I can show you how it should look like, because luckily I wrote a blog post about that, and it's an old one, but it has the same things here. So here you can see how it should look like. So what you would see here from tracing is that there was an initial, I mean, in tracing you have the whole trace, and that is made up of spans. And those spans can have children, and they could also be like sequential. In this case, there's no sequential spans. But so there was an incoming request into the gateway. And that then called the hello handler. And that hello handler went to the hello backend proxy, so to say, which is calls the backend. Here we get another incoming request, and finally we have the hello handler that gives us the nice message. Okay, and what you also see here is that you have the timings. So a lot is lost in network communication in this simple example, obviously. And what you also could see if you could click here, which I cannot do in my blog post, you could then open a detail view and see more attributes of the particular span. For example, also all the log events that happened. And then you can go back to the log events. So this is like you can navigate from logs to traces and vice versa. And in my opinion, this is super helpful if you have a like non-trivial system, which is a little more complicated than this one here. It's so important that you have tracing, because else you are sort of flying blindly and you have to guess from looking at logs what has happened, and you always don't have the context. So having the trace ID, having the ability to look at the overall traces is very, very helpful. Okay, so let's now take a look at the code again, how to do that in code. Okay, and there's two aspects to it. First of all, how do you do it locally? How do you enable that those traces are emitted? That's the first step, and that's pretty easy. And then the second, which is harder, is how do you make sure that the trace context, so information about tracing, is propagated from one service to the other? Like here, from the gateway to the backend. That's a little tricky. And here is where OpenTelemetry enters the stage. Let's do it like this. Is it okay for you? Can you read it like this? Okay, great. Let's not take a look at the initialization, but instead go, let's say, to the gateway, which has this backend RS. The backend RS file contains this backend struct, and that has a hello function method. And that essentially calls using gRPC the backend. Therefore, it's called backend. Right? And if you look at this attribute here, instrument, that comes from the Tokyo tracing library. Okay, and that's all you need. If you put this, I call it annotation, onto your functions or methods, you get tracing. You can rename it if you want to. I did it in this case because hello is used everywhere in the code base, so that makes more sense. You can skip parameters. Parameters have to have a display or debug implementation. Self, in this case, doesn't help here, so you can skip parameters. You can add fields if you want to. So it's pretty flexible what you can do, but in most cases, just putting this instrument attribute on your function is all you want. And then you get traces for free. And that even leads to tracing information be added to the logs by default. So this is the info logging macro I showed you earlier, or it's the output of it. And as you can see here, no, sorry, it's not visible here. I'm sorry. So what I wanted to show you here is that in addition to this stuff, you also have the spans. In this case here, you don't see a span because this hasn't happened inside a trace. It's just the startup message. Yeah, but anyway, the log messages would usually contain all the spans that have happened. Here the spans are an empty array. Do you have a question? Oh, okay.
No.
Okay. All right. Okay, so this instrument, very easy. Just put it on your functions and you're good. And if you just have a monolith or a single app, whatever, that's all you need. Then you're done. But when it comes to this, yes?
So what kind of tracing events is annotation generate now? Like one event when entering the function and one when exiting the function? Or is there
No, it will. Tracing is not events. Tracing is spans, okay?
right, yeah.
Events are logging. Spans are, well, you could call it an event, but it's different. It has, so span has like a start, time, and source location, whatever, and an end, time and location. And it does all of that. So this essentially has a start and end, which is the scope of this function. Okay, so the parameters, well, we skip self. The parameters, you could even add the result that the function is returning, which I don't do here. You could also add that to the span if you want to. So the function defines the span. Does that make sense?
Yeah. So in case, since this is an async function, the end of the function would then be the termination of the code.
The termination of
The code, right? Since I mean.
Yes, sure. Yeah. So that's also the good thing here. It seamlessly, so this macro and attribute seamlessly works with futures.
Yeah.
You can do it in code, but then it gets a little harder for the futures.
Maybe one more purely Rust-oriented question, as I'm not an expert. For example, the skip, the self, is it that this is just a string that the compiler is going to read, or does it know about the parameters of the function that are defined there? So
Yes.
does it get auto completion, or does the Rust analyzer know this?
That
Would be interesting how this is done.
Well, it's a macro, and the macro knows about the AST, so it knows about this function. Whether Rust analyzer is able to autocomplete in macros, I doubt. Let's give it a try. Yeah, you can.
But was this visual code or was this the Rust analyzer?
That I don't know. Let's not ask. I don't know. Yeah, but that's a really good question. Yeah. All right. So let's talk about distributed tracing when it comes to send the propagate the trace context from service A to service B. Essentially, it's not that tricky, but it always depends on how those services talk to each other. If it's HTTP or gRPC, which is more or less the same at that level, it's usually HTTP headers. But you can also propagate trace context to, let's say, Kafka. In most protocols, you have headers, and then you just put stuff in your headers. On the sending side, and then on the receiving side, you've got to extract it from the headers. Okay? So injecting and extracting are the terminology used by OpenTelemetry. And I can show you here how it is done. And if you look at this code here, we already use this hello client with interceptor. So I'm using a particular gRPC library. It's called Tonic. It's pretty cool. And that gives a lot of code generation based on top of the proto files. So this hello client with interceptor is already there. And what this interceptor method gives us, or it's a function, is that you can, well, define an interceptor. And that is this send trace function. The send trace function here takes a request and gives back, well, a result of request. Typically, you give back OK with a request, and then you do something. So in our case, what we do is we do this injection. You don't have to look at the details, but essentially, we do propagator inject context. So we put something into the propagation. So we have this metadata injector here that uses the gRPC metadata, which essentially are HTTP headers, okay? So we put the context, and that is the trace context from the current span into the headers, and those are sent across the wire. And then on the other side, let's take a look at the back end. Sorry, I went to the wrong file. In the back end, we start our server, and we have a trace layer and so on. What we do here is we map each incoming request with this accept trace method. And what that does is it looks at what is in the current request. It uses this extractor, so it tries to extract trace information from the current request and then derive the context of the current span from it. So if that sounds too complicated, this whole trace context, just think of the ID of the parent span, okay? Because if the request has started at the gateway and then is moved over to the backend, then we already had at least one or maybe two, three, as we have seen, spans, like in a hierarchy, at the gateway. And then the first span that is created at the backend must be underneath the gateway spans, okay? So let me go back here. It's this one here. So here, the orange one or red one, this is created underneath this span. And that's all that happens when you extract or try to extract the trace context from an incoming request. So it's just a couple of lines of code. It's not too hard. You just need to be familiar with the API, but that's really all that you need to do. And with all that in place, maybe a little more here and there, you really get a lot of very cool and helpful tracing information for your services. And personally, I've introduced that at a large company which has like very high frequented services, service-oriented architecture with 20 to 50 services. Sometimes when one request comes in, it goes through like 5 to 7 different services. And there, this was so enormously helpful to identify errors. Because as I said initially, if some service in the chain somewhere throws an error or logs an error, it usually is super hard to understand why this happened. You see, oh, there was this error, but why? And if you have the whole context, the whole initial request, and how it went through the whole logic in the various services, then you get usually much easier at a conclusion, what went wrong, whether the request should have been rejected, or if it's a bug in your code or whatever. Okay. Questions?
Yeah, so none of these functions that are for adding the trace or extracting the trace, like you change the type of the request, right? So if I just talk to somebody who's not aware of tracing, they would just not look at the data.
Yeah, exactly.
Yeah.
Exactly.
The other question that I had is, so my understanding is that like, if I look at the trace, I basically have like all of the information, like all of the parameters to the function, everything that I need to reconstruct the context. So is there support for also like replaying a trace so that I can like reconstruct a certain log on the executable?
Well, that's a great idea. I'm not aware of any standard tool for that.
It's not part of OpenTelemetry.
No, not as far as I know. It's just for observing stuff, not for replaying as far as I know. But I agree that this could be super useful if you really, yeah, use that to reconstruct requests, to even get more deeper insights into the problem at hand. Yes, that could be cool. Okay.
Question about the gRPC. The injection of the trace ID is done manually, right? You had to implement that yourself. It's not supported by Tonic.
Tonic only supports injectors. It doesn't have built-in OpenTelemetry support. No, I had to do it sort of myself. If you look at that code, if you
So basically, the key that you use for in the metadata is defined by you, right?
no, I'm using this header extractor, and that is a struct in this case that I have written. The injector, on the other hand, is already available. Yeah, anyway, so you have the you should see already a to do. So there's a crate. It's called OpenTelemetry HTTP, and there's the code for that. So OpenTelemetry defines the semantics. It defines which names have to be used. And for the trace context propagation, I think it's 2 at least. It's trace ID and span ID, I think, or parent trace ID and span. I forgot it. So, but that's defined here, and you already have like. I had some issues with various versions, so I had to implement that on my own. But essentially, it's there, and you can just reuse it.
Okay. Another question is specific to Tonic, the injection implementation. Could you go there?
Sure.
Yeah, I see that you're trying to create a metadata value from the value you're passing. Was that to circumvent a current issue on Tonic that you cannot just mutate metadata value?
In this case, I have to implement the injector trait, and that the injector trait here, that is from OpenTelemetry propagation. So I just have to stick to that thing. And they are just using plain strings, I think, or yeah. And I have to take those strings, or str and string, and then convert it into the format which is understood by Tonic. And if you think about Kafka, it would be the same thing. So essentially, you have to do your mapping. OpenTelemetry just says, okay, it's strings, keys and values are strings. It's just some UUID like hex strings. And then you have to, if you use a text-based format, it's simple. If you use a binary format like gRPC or Kafka, I don't know. But if you have binary formats, you have to deal with that. So essentially, I had to deal with that. As you can see here, you need to use those try from or similar things. And you could, I mean, I don't know if I should have dealt with those cases because they wouldn't happen because I control both sides of the thing. So I could have just used unwrap or expect because I control both things. But yeah, you need to deal with it because you're integrating into this injector API.
Have you tried what happens if the inconsistencies in the reporting, like a distributed system with the clocks are a bit off, so this spans inconsistency in the time, or a parent ID referring to a span that is not your report has already been closed?
With the time, I haven't seen issues. It's a good point, but I think they will. as the spans are, they are built using a hierarchy, so time doesn't matter in this case. So it could be, in theory, like that the parent span happened later than the child span, but yeah, then this would be because of clocks. But the other thing you mentioned, that's really, that can happen in practice, and then that has a relevance, because you send those span information across the wire, in my case to Grafana, and those packets could get lost. I mean, the open telemetry collector that is being used here will do retries and everything, but yeah, things can go wrong. And I have, in fact, sometimes seen incomplete traces. Yes, it happens.
Does a reporting try to fix incomplete traces so they are somewhat in right order, or does it just drop the pieces that are inconsistent?
No, what I have seen here in the UI, like here, instead of these nice things, I just saw incomplete trace. Like it was written there. But it happens rarely, because if you're using good tools like the OpenTelemetry Collector or Grafana Agent or Datadog Agent, they will try to reliably send information to the backend. So if there's a network issue, it will retry and stuff like that. So it happens really rarely, and I think it mainly happened with my pet projects locally. I can't remember exactly. In production, I haven't seen that. Haben wir Zeit für weitere Fragen? Eine letzte, ja.
Yeah, last question? No?
I assume with logging, one of the main functionalities is that you can choose a log level, right? You can say, I'm only interested in arrow and above, and then you don't have to pay for a lot of
Yep.
Is there a similar mechanism for the tracing?
Yes, of course. Good question again. By default, the spans will be, where's my backend? By default, if you use instrument, the spans, they also have the same levels. They will be at info level. You can either change the default if you want, so they are always debuggable. But if you want to have some more important spans and other less important spans, you can always put the level here. You can say, okay, this is like warning level, or this is debug because it's not important, and then in production we will turn it off because we are only interested in info. So that's possible, yes. Okay, thank you. I hope you enjoyed it, and have a great rest of the evening.
All right, thank you, Heiko. Yeah, then let's have now a break, 20 minutes. So like short 8:04. We will continue then with the next talk. All right, enjoy.
Ja, doof, gell, dass es geklappt hat.
All right, welcome back, guys. Online. I hope now everything is working. And I think we need this one here. So the beamer is booting. Of course. No one saw that. All right, so very good, very good. So welcome to the talk. So I want to give you an introduction, just a brief one, about like how to build a parser for a domain-specific language with Rust and PEGs. So we will talk a little bit about grammars and the PEGs, parsers, and so on. But it is specifically a takeout of a pet project of mine. So I tried to synthesize some details and learns, but made it kind of very simple. So it's not the most realistic thing. However, I think there are good things to take away from it. Let's start first with having a short definition of a context-free grammar. So I don't want to bore you to death. So it's very briefly that you know, a grammar contains out of tokens, and there are like terminal symbols, and there are also non-terminals. And with those kind of things, we can like define production rules of the syntax eventually, right? So yeah, a few examples are here, like in Rust. Yeah, we have this let and if and else. Those are all like reserved words of the grammar, right? You all know them. And you cannot have a variable named let or something like this, mostly. I mean, there are some grammars where these things are possible, but yeah, I think this is like really tricky, and the default things we are talking here, you cannot have such things. Then the parsing expression grammars was like a little bit of a formalism introduced then in 2004. It is kind of pretty similar to a context-free grammar, like from the looking, but the behavior is a little bit different. So just think of it as a regex-based grammar with a huge focus on readability, so that you can really understand what's going on. And this brings us to a Rust crate called PestRS. And this is a very, very nice library that gives us, you know, this sort of specific DSL. It's an own grammar, the PEG grammar, that allows us to express our language very nicely. Then also, like, it is really fast enough for most cases. So on the bottom you see here, there's a takeout from their website that you know, JSON parsing in pest versus norm and versus Serde, and you see the figures here. So it is really slower, but still really fast enough. So, and the things I want to highlight is there is a really excellent integration with Z, VS Code, and Rust Rover. And yeah, bonus tracks compiles to WASM, so it can really run everywhere. They have this nice playground on their website. It's really helpful. If you want to just, you know, toy with an idea, you can do this online. It's really cool. Then let's have a look at the syntax for those pest grammars. So this is really, again, like just an extract. So there are more things. So yeah, as with the context-free grammar, so we can have terminal symbols, usually like strings we would define in double quotes, single characters in single quotes, and also non-terminals like rules are possible. And there are some built-in non-terminals. So this is really just a small extract. There are more. You see it on the bottom. There's the reference. You can see them all then there. And yeah, then you can chain things together. And yeah, this underscore on the bottom just describes something that you can put in front of a production rule, and no real like terminal will be produced. We see this then in practice. All right. Let's now have a look at this example. So this is, as I said, this is this extract of this toy project. So it is about having this HTTP language. As it's really similar, like how like request logs are looking, except that certain details in the headers are a bit different. So you define your HTTP method, then you provide a URL, and then the version behind, and then below you can have as many headers as you want. No body and no other like fancy things, really basic. And for this, we would have a grammar that looks like this. We have on the left side, you see, or like on the bottom part, these are like tools. They all have this underscore in front of this curly brace. This means they don't produce something that you can name. They are just like tools in your toolbox that you can use later on, like atoms, right? And then if you go a little bit lower, for instance, to the very bottom, the URL. The URL is like defined that you have the scheme from above, which are just the two literals like HTTP or HTTPS. So pretty natural. Then followed, so this tilde means something is following it, colon // right? And then the host. The host, again, you can see above, is defined by an alpha num followed by either a dot that is followed by an alpha num, and this can repeat like the star. So it looks kind of familiar like regular expressions, but it also has the verbosity that those things are named, and you can follow the chain up to the atom definition, if you will. And of course, that's not everything. So we need then, after the URL definition, we need to take care of headers, right? So content type, colon, and then some arbitrary value. So it's basically key value pairs, right, that we can define, and that is expressed here. Header name, again, alpha num, or a dash, and then can repeat. Header value is a little bit different. And then this is like defined as a header, so header name followed by a white space that can repeat, colon, right, and then again a white space that can repeat, or value, and a value. And then headers, yeah, like a list, right, is just defined like a header followed by a new line and a header that can repeat. Pretty simple, I would say. Then after all this, right, we have then to define the request itself. So the whole file, as you see on the top right, this is what we call the request. So in the beginning, you see SOI, this is like start of input, and then you define like, where it starts, it's the method, white space, the URL, and then it can follow by the version, but it does not need to. And then there's a new line with headers, but also this is optional, right? So you can have the most simplest request, which is just get HTTP host name and the path, and that's it, right? Very, very simple. And here for completeness, that's the complete grammar at once, right? All the pieces we have seen already. So it's nothing new here. And that's it, right? And this allows us to define this very HTTP language. It's of course not complete. So the URL definition is far from complete for the RFC. Also the HTTP methods are not complete, but you get the gist, right? It's kind of very expressive to define your DSL. And that's the major message here I want to send. And now let's come to the Rust side, how we would have an implementation, how would this look then in Rust code. And yeah, batteries included. It's really as simple as that. You would define a struct, and then you annotate the struct with a procedural macro to name the grammar file, right? So the file that we have seen in the previous slide, it's called request.pest, and you derive the parser, and that's it. And you get all the implementation behind the scenes, so all the lexing part and everything. And the impl here that you see is just optional. You don't have to do it, right? Because you could like, just call what you see here, the inner parse yourself, and you then have to hand over the rule. As you see there, the first argument of the parse method is called rule request, and this corresponds to the grammar, right? The request rule that we have defined on the very bottom is named accordingly. So you say you want to parse this input stream and you want to get a request out of it. You could also name other tokens if you know that you have a subset of input stream, for instance, only the URL. You could say, I want to parse it, and the rule should be URL. And you get the URL out of it, right? So this drives basically the expectations of your parser. And then let's come to how would you use such a thing. So what's then the next step? Because there is no AST definition or anything. So what you can see from the return value of the parse request function, it is returning a pairs struct that is generic over rule. And this pairs struct is a bit of a thing that it took me some time to get used to it. I still don't like it very much, but you can work with it if you get the mental model, right? So it's a nested structure that can that gives you iterators through the definition of your grammar, right? So it starts on a request level, and in the request, in the first line, we have then the method and the URL and the version. And below we have the headers and such stuff. And exactly in the same way, you can navigate now with this code here, with really like for loops, for instance, like as you can see in line 13.
Sorry, quick question.
Sure.
Where does this rule come from?
A good question. Very good question. Wait just a second. I will reveal that in a bit. But that's exactly the sugar that you get from the parser, if you will, right? So behind the scenes, this macro will produce you some code, right? As macros do usually. And this specifically is an enum that has an entry and value entry for every production rule in your grammar. So in this rule enum, you find the request, you find the URL, even the white space and the other things are there. But we'll come to this in a second. Very good question. So this pair implements into iterator, and with this you can loop through the pairs. And here you can see it's wrapped into this dive in function, so you can recursively call it and dive down the tree, right? The syntax tree. And this is a little bit abstract. So what it would produce is what you see here. On the right side, you see the output of cargo test. And you see on the indentation level that is similar to YAML, right? Just to give you an idea what it will do when it dives down, right? So if it dives down into the nested structure, it will add two white spaces. You will see it starts with requests, then one level deeper, it finds the method named get. Then on the same level, it finds the URL, and level below, for the URL, it finds the scheme, the host, the port, and so on, right? I think you get it, right? It's very natural as you have defined the grammar. It will dive down and produce you a syntax tree similar. And since your code would normally not look like a generic loop, right? You would want to validate certain things that, for instance, a port is within a certain range, for example, right? That you cannot express in your grammar. You can say they must be numbers, but you cannot say beyond 65,000 is not possible, or something like this, right? Such validations you would put normally when you construct your AST. And how you could produce an AST is something that you see here. So now the rules comes back into play. You see here the rules are all well named. So we start with the pairs. We call next on it, and we get the request out. And you see the request has this as rule function on line 7. And this returns you an enum value from your syntax tokens that you're going to expect. So here it matches, it is rule : request. Then on the next thing, we turn the request into iter again. And this gives us all the request parts, and then we can call next. And the first thing that we expect is that the method rule is produced. And the same thing here below. After the method, the HTTP method, right, we would expect the URL to be named. So we say, okay, the rule now should be URL. And within the URL, right, again, it's called into iter on line 27. We expect the next token that is part of the URL, which is the scheme. It starts with the scheme, and so on, right? So with this, you could navigate through your expected syntax tree, and then you can produce your AST nodes out of it. So yeah, the unwraps are not nice, of course. You would not want them. And here again, you would see, you know, what would be produced. So the print lines here you see now below. And the interesting piece is also, if you see at the first line, the request and the content is really like the string that you see is the whole file, actually, right? So it's get the URL \n, and then the first header, again \n, and the second header. So you get them all. But if you parse further, you get them like sliced into the pieces that you need, that you have expressed in your grammar. So it is kind of handy. Yeah, sure.
Do you know why? I mean, it seems like it can infer request method and all these things. Like, so the pest has the knowledge about the structure.
Mm-hmm.
Why does it then just return pairs and not build a structure that reflects the structure of the grammar?
It's an excellent question, and there is a solution for that. It's an extension to pest. It's just briefly named at the end, but if we have some time, I can show you the code where you can have to do some further annotations to map it to the structures that you want, because these pairs, they're really dumb. They are just a span, span again, but in your input, right? You have a named span that says, well, from the input at this line at this column, that long, you find the rule that is named request, for example, or method, right? There's no real meta information available. It's just the spans. And if you would map, for instance, the rule methods that we have defined in the grammar, we said the methods are get, post, put, and delete, for example. Normally, you would want to map them to an enum maybe as well, right? Say there's a Rust enum, makes sense. But PES is not that smart that it understands, there are some strings, they can all occur, and I would just put a representation of those strings into an enum. This is something you have to define, but you get in this other crate, you get some annotations, again, some procedural macros that let this mapping happening in the background. So you don't have to implement it yourself. You just have to name the structs and say, this rule should end up here. And if it's a simple one, like what we just discussed, then it's pretty easy. And if it's a bit more complex thing, like the headers, then you have to tell a little bit more how those spans should be mapped into the structures. But yeah, that is really, I was asking myself the same question, why I have to do this myself? If it knows already certain things, and then, yeah, the other crate came to the rescue. Yeah, and if sometime I can show you the code. So the next thing that normally comes to mind when you talk to people about parsers, it's about, but those generated parsers, they produce poor error messages. I cannot give that to users. They would never understand what to do, blah, blah, blah. There's a huge, huge argument about that they're normally not good. Here, I would say they're not perfect. So as you can see here, I produced an input that is get, and then FTP, hostname, and whatever, which is, of course, not conform to the URL we have defined, right? Because we were very strict about the scheme. So we're getting an error. And this error representation, I would say it's still kind of fine. It tells you where exactly is the problem. You see, similar to the Rust error messages, right? You see the string and you get some insight on where the problem is. However, what I would expect here is the scheme is defined very, very simple. 2 strings are allowed. It could give here even hints that it expects as a scheme this and that, right? This would be more user-friendly. So that's the only thing that I can really complain about, that it's maybe not good enough to give to users, but you get already something that you can enrich and maybe rework the error message a little bit, and then it's good enough maybe. So yeah, for that far, yeah, you get a lot of things for free. And that's really the example that I wanted to give. So the next iteration would be that we introduce a body maybe and make the language a little bit more nice. But yeah, this is just yet another rule in the grammar. So you can really iteratively extend such a grammar and work on it without having really big troubles to, have huge implementation on your Lexa or extending some scanner tables and stuff like this. Yeah, it lifts really a lot of things from your shoulders. But of course, those PGs, they have some limitations. This is, again, a little bit of syntax and grammar theory. Don't bother too much with it. It's really not that much of a problem. I mean, there's this ambiguous grammars that you might end up needing or that you may have. For instance, like how in Python if else would be happening, then you always have this situation that you don't know really where are the brackets around a certain structure, right? Or where does the first end and the second. So to give this a little bit more specific example here. So the statement rule would be defined like this. And you start with if white space condition, white space then, and then again a statement, or another production rule, same as above, but then comes with the else and a statement, and then another statement is just a pass. Then you may end up in the situation where the parsing leads you down a road that is just not right. So for instance, if you would turn that a little bit and say the most specific rule, so the longest usually, comes first, and then the less specific rules comes later, you would get different results. So let me go back again. So this is the unspecific first. You see on the bottom, statement, condition, C equals D, and then statement pass. And here it is really like statement pass, and then the outer statement pass. So this is, again, you see it in comparison. Okay, let's just, draw some takeaways to keep it simple. So you would really like, when you write your grammar, you would write it like, as you would parse it, like top down. And you keep the specific cases always at the beginning. And then you come to the less specific cases. And if you follow this rule, mostly it works. So, I mean, I never really encountered this with those simple DSLs, right? If you intend now to implement a programming language, it might become tricky. But for other things, it's really not a problem in reality. All right, and we are already at the end, so you made it. Let's conclude a little bit. So PestRS gives you the possibility to maintain really a higher level of abstraction of your DSL. So you don't focus on implementing the lexer too much. You really express your grammar first. So you can really put focus on how you articulate things. You can really make things nice, and they are still maintainable. This is, for me, the most important part. I mean, Lex and Yak or Bison and so on is also maintainable if you have enough tests, but it's really tricky. You have to get into it, and you have to wrap your mind how it works, really. And this is not the case here. It's really just more straightforward, at least to my taste. Yeah, and then we have the batteries included. As I mentioned already, these crates like from Pest or Pest AST, they lift also so much from your shoulders. They come to there are other trickinesses than inside if you have very specific things. So you have to learn their syntax, how those macros would be used. But still, if you are more into using macros basically and write less boilerplate for that, then I think you get really a lot of value out of them. Yeah, and again, it gives you the possibility to have fast iterations on your DSL and enhance it over time, because you don't have to rewrite your lexer that much. You can focus on other things. And the portability aspect with WASM, I didn't highlight it in the examples yet, but this would be also like something that, in production you would ask, well, it's nice that you have your grammar, but if you cannot only have it in Rust, well, then yeah, it comes often to a showstopper situation. But this is luckily not the case here. So yeah, with that, want to open for questions. Yeah, go ahead.
So it's only implemented in Rust, right? It's only PestRS.
Yeah.
There's no
That is a good question. I think it is only implemented in Rust. But yeah, I think I'm not really sure, because they have these IDE integrations, right? Also with Rust Rover, and there I was always curious how they have managed it. if they also went down the WASM road and have then just Java bindings around or Kotlin bindings around. But I don't know really, so I didn't check it out.
I think for VS Code, they might just use the LSP, this language server.
Yeah, might be. And there, I mean, WASM is anyways not a problem because it's all the Node ecosystem or TypeScript ecosystem. But yeah, good question. Maybe double checking it. But yeah, I would say they do dog fooding their own stuff. So yeah, would make sense.
Do you know if this can compile to regex or something? Like if you define it in test and then get your regex string out of it, because it seems much more convenient to write.
That is a good question, actually. I did not check, but would be a natural next step, right? To compile it down to, you know, the stripped down bare bones regex version of things, where maybe group matches are there. But I'm not sure. Maybe there is also like a certain feature then not there, because this grammar gives you also a little bit more flexibility on things. I'm not 100% sure if they match the same like grammar standard, so to say, right? There are these different grammar like complicatance levels, right? So if they translate to each other, I don't know really. Yeah, but would be good to figure out. Maybe there's another crate that would just allow you exactly this, to compile it down to regex and then have groups, for instance. Yeah. All right. Yeah.
So you showed the errors at runtime when the parsing fails, but what about the errors at compile time? Like if I have an error in my grammar, in my test file,
Right.
what is the experience there?
That's a good question. I don't know. We can try it out if you want. Let's see. Maybe we can. Yeah. Let me. Is it readable? Okay. Then let's jump to the grammar and mess something up. Let's say we remove this bracket here, for example. And let's see, there should be a cargo test thing somewhere. Wait. So let's start at the top. All right, here we go. So the macro itself complains that there is something not right, and it tells you even what's expected. So, well, it does more than pest itself does, right? It tells you what is expected here. Yeah, which is a good start. But
also shows this in set. I just saw like it.
Mm-hmm.
Like if you open set,
yeah.
Like it also shows it.
Yeah, the Rust analyzer probably. How can I?
Best language. So.
Yeah, expected open brace. So yeah, it's a little less readable, but yeah. All right, I think, did this answer your question?
Yeah.
Okay.
To some extent. Yeah, thanks.
Okay, good.
You know, there's some other languages or like larger languages used to parse, you know, like
That
actually just for themselves use, but is text used in production somewhere, like not just for.
Yeah. So the question is if pest is basically used in production.
Yes.
Yeah, I can give you one example that I know for sure that pest is used. There's this crate from Mitsuhiko called InstaRS. It's a snapshot testing library. I don't know if you know. Gives you roughly, it gives you the possibility that you define your snapshot, or that you can even use a command line tool to exercise your tests. And instead of hard coding all your assert equal statements, you know, it would snapshot them, save them into files, and then it would just run through and give you diffs. For instance, if you do request snapshot testing, so you get a response back, this response are normally pretty huge. You don't want to have this in your code. You want to externalize that and just want to be sure this passes. And this language he is using there is some sort of a YAML style based. So it comes with some headers on top and then the body. And as far as I know, he uses PEST for those test fixture files, this very grammar he has in use there. But there might be more. Pretty sure it's really healthy developed. So for instance, the Z extension was just recently popping up on the website. So Z is also kind of a new kid on the block. So people are eager to use it. And yeah, would not be surprising that it's used more wider. Yeah.
Do you know if there's a company behind it, or is it just a community?
As far as I know, it's just a community. It's one guy. Or no, maybe. Sorry, yeah, I shouldn't say that. I was under the impression that there's just one guy, but they have their own GitHub org, and yeah, he also accepts GitHub sponsoring. So if you want to support him, feel free. And yeah, I think the project is still active, active, developed and maintained. But yeah, also pretty stable. So it's nothing new, nothing that you should, in my opinion, that you should not use in production. It's definitely ripe enough. All right. If no further questions, then let's conclude. Let's.
Instead of the pairs API.
Excuse me again.
We had the question before. If we don't want to use the pairs API, but have like a static API that knows about the structure.
Ah, yeah, right. Okay, let's have a look at this. So, concept of an AST, right? It gives you an abstract syntax tree that is not 100% as your grammar is. Maybe it's pretty similar, but not quite. So it gives you the possibility to define certain things and have your first iteration on validation, so to say. So this is how I would like define an AST for this language. So you have your method enum, you have your scheme enum, your version enum, and then you have a struct called URL. And there you find a scheme, you find a host that is a string, might be worth an own type host that comes with all the restrictions that we put there, and so on. And the path may be the same. And the vec of params comes here, body even, and the request structure. So how I would now use this other grade that I mentioned to produce out of the rules those structures, those contents, right? So that I don't have to implement it myself. I would use again a derive macro and like call it from pest. And here I define the rule from this rule enum that matches or that correlates to this very struct, right? And as I said, for enums, it's kind of pretty simple. They not look totally different. It's easy to map them. So it's really just this code, and then you would get produced a method that is valid. But if we go to a little bit of a more complicated piece, complicated is relative, but let's say we have a struct called port, which wraps a U16. But yeah, you have already this mismatch that you know the parser just knows strings, but you have to map them to a new 16. So you would have then to define again this macro on this very field, and you then have to speak this this language of the macro itself to turn the inner span into a string, and then you pass it over to the parse function of string that returns you an U16, and then you do something with the result. For instance, unwrap or default, which is, of course, you would not default, right? You would error or something. But yeah, let's just assume the port was optional in our case, right? In the grammar. Just to open the grammar again here, we said in the URL port is optional, right? So we could say the default port 80, for example, is inferred there when there is no value available. So yeah, that is definitely possible. And then when you come to other like more complicated structures, the same pattern repeats, right? So you turn your span into a string, and then you do something with the string and map it to the final structure. And here it's just a like str to string thing. Also causes some you know, some things to do, and so on. So with this, you can at least save boilerplate code, but you have to buy into the grammar of this macro. I mean, yeah, you have to die a certain death, right?
Can you show the signature of span?
The span itself.
Yeah, this function. Okay, so it takes this. That's the output of the function.
Yeah, so span is this was not the right. So span is something that is part of the parsing structure. So the same level where the pairs operate. So maybe we can jump there. 1 second. Let's see. Let's jump into pairs. So pairs is abstract over the rule anon, and it gives you this start and end. And this is usually what produces a span, because it would be expensive to, you know, copy a string all over every structure while parsing. You would just keep those markers where you are in your input stream, and when the time comes you really need a string out of your span, then you use the span structure. It provides you with a string, and then the costs, like copy costs, comes in place. Yeah, so I think maybe somewhere here you would even find it. So a string then, yeah, does exactly this. It gives you a borrow into yeah, into the input string. Yeah, that's really it. Probably there are more fancy methods. I never took the time to explore all the capabilities. Maybe you can rewire things then and have, you know, an own implementation for parsing the AST that, you know, that is closer to what they offer, but you know, save some boilerplate. Yeah. All right. Further questions? No? Yeah.
One last one. If you look at the AST file again,
Yeah.
How
This one or the other one?
Yeah, one of them. Probably the more complicated one is the
Okay.
good one to look at. How does that compare to what you would do with norm? I never used norm, but I expect it to be kind of similar.
Yeah. That's a good question. The thing is, I used norm before the version of a major rewrite, so I cannot really tell you what have now changed. I heard only that it's now way more better. So norm is basically the idea of reusing bits and pieces. So like combinator approach, right? That gives you then also the structure that you want. So very similar to this, for instance, you tell them that, I don't know, I take these bits out of my input stream, transform it with another chain of function into that, another chain, and so on. And then in the end, you get out what you want, and it's put into place. So yeah, it's similar as if you read this as a, you know, chain of functions. Yeah, it reminds me a little bit of norm, but norm comes with certain primitives. So to convert, I don't know, for instance, this string to U16 or something like this, probably this exists already. Or take the first 3 byte, or even checking bits and do them this and that. So you can construct also conditionals and stuff like this. So NOM has way more primitives to express very powerful combinations. At least this was some years back that I checked. So yeah, maybe it's similar. But what you don't get with NOM is this nice overview of your whole grammar, right? The knowledge of your grammar distributes among certain structures, all your structures that you have, because you wire the instructions how to parse you wire them into your structures, right? And there's no meta knowledge of what that means. So you don't get the grammar overview, for instance. You don't get this file like we have here, right? That would tell you all your language, the primitives of your language, how it's composed, how you can read it, what's right and what's wrong. So this high level view, you don't get that with NOM. You really only have these parsing primitives and the annotations. So if you will, the building instructions are there, but no higher level concept, what they wire together, so to say.
And I guess this is quite valuable if you want to write some specification that people do understand, they have no Rust knowledge.
Exactly. For instance, if we look at the RFC for the URL itself, right, it is pretty similar expressed, like here, really. They define the scheme, right? And of course, they don't say HTTP, HTTPS. It's a bit more complicated, but it's, again, some rules, right? So this BANF, Bacchus Naurus form rules that are common in syntax, they use them, right? So, and it's pretty natural to translate those rules into such a grammar because they look pretty similar, and they would also behave pretty similar while parsing. So it's kind of natural, yeah, if you operate on this level, or if you have a very complex language that you have to, for instance, SQL as a language, right? If you implement a database, SQL is a huge language. You have so many features, and even things look similar. For instance, a select statement, but a select statement in an update statement that you can also use within is a totally different definition than a normal select statement because it has some limitations, for instance. And if you then have, write your structures and distribute all this, I think you get lost. No one really would have a really overview about the language, and then it's pretty hard to maintain over time. Huge projects, I would not recommend to do it. For small things, it's even faster. Maybe it's worth it, yeah. Okay. Then thank you everyone for your attention. It was a pleasure. And I would say now let's conclude, have some more drinks, socialize, mingle, and hope to see you next time.